In order to understand many of the properties of gases, we need to first talk about pressure. And when we talk about pressure, we can say that gas particles exert pressure by colliding with the walls of their container. And the way we express pressure is we can say that the pressure is going to equal to the force per unit area. And the number of collisions with the wall, the container that the gas is encapsulated in, is going to be proportional to the pressure. Initially, we can say that this pressure has a units of newtons per meter squared, which is known as the Pascal, abbreviated PA. The more collisions we have per unit area, the higher the pressure. So if we go back in time and think of ourselves as a chemist in the early 1600s, the thought at that time was the atmosphere has no weight. And this is something we know now that's not true. Back in the 1400s, everyone thought the world was flat. Well, now in the 1600s, we're starting to look into different things, and the thought of the time was that the atmosphere has no weight. Well, there was a scientist by the name of Torricelli that he thought this was definitely wrong, and he set out to prove everything wrong, but he couldn't do this using a conventional balance. So Torricelli needed to invent some type of equipment to help him prove this theory. And he invented something called the barometer. And the barometer experimentally measures the pressure of the atmosphere. And what Torricelli did was he took a container and he filled this container with liquid mercury. So we have a vial here contained with liquid mercury, and in it he put a tube that he inverted. And what happened was, based on the height of the liquid in our container, the mercury would rise up the tube, and we had to make sure that this tube was in a vacuum, right? So we have a vacuum here, and there's going to be some air in there, and we're going to measure the height of the mercury based upon, or the height the mercury goes up the tube based upon our height of the mercury in our little container here. Okay, so Torricelli goes and he climbs to the top of the mountain and measures the pressure at an elevated height. And in doing so, the measurement of pressure decreased at higher elevations. And this really gained the attention of a guy named Blaise Pascal, who knew that Torricelli was right, and they both worked to convince everyone that they were right. And they finally did show that the atmosphere does have a weight, and it's contained, there's gases there. Okay? So in order to kind of communicate this pressure to everyone, they had to come up with a unit. And there's a kind of a baseline that we use called standard atmospheric pressure. And we're going to define standard atmospheric pressure as the typical pressure at sea level that supports a column of mercury 760 millimeters high. And from this, we can come up with some various conversions. We know that 1 atmosphere is equal to 760 millimeters of mercury, which is equal to 760 torr, which is equal to 1.01325 times 10 to the 5th pascals. Okay, so and from this we can see that 1 torr is going to be equal to 1 millimeter of mercury. So these are the common pressure units that we're going to use throughout our text here, and these came from the work of Torricelli and Pascal. So they used a barometer, and another device you might see as you encounter some of these problems here in the textbook is that a manometer is a device used to measure the pressure of a gas or liquid in a closed vessel. So in the open atmosphere, a barometer is going to be very, very essential for us to determine pressure, and you will see this used by, the weathermen on the news. But when we do chemical reactions, we typically use closed vessels, so we'll probably use something called a manometer to determine the pressure of the reactants and products before and after a chemical reaction.